pick up where we left off kind of yesterday with piecewise functions. Okay, so to get a 3, you just have to show me that yes, you can graph piecewise functions. To get a 4, you have to kind of work backwards, and given a graph, can you write the function? And we'll practice both. Alright, so there are many real-life situations that are modeled by piecewise functions. We kind of talked about this today, but some other ones that would pop up or you would see: stock prices, because you have that broken, jagged graph because it changes so often. You have movement or speed of a vehicle, because again it changes so often. You can't go 50 miles an hour the whole time that you are going. You have to slow down, speed up, all that stuff. Some other piecewise function relationships, sometimes growth of something, because in that case, like if you're looking at a kid, they don't grow at necessarily a constant rate. You're going to have years where they shoot up quite a bit and grow maybe 5 inches, and then some years where maybe they grow only 1 inch. And there's other ones that I'm going to add here, but we're going to actually probably add them together. So I want you to take a few moments and maybe pause the video and think of maybe some other situations where if we were to graph that situation, you would have a piecewise function. We'll add it to this other side of the list. Alright, so that's why we cover them, since you're actually exposed to this type of function more often than you probably know. And you'll see it pop up, more and more now that you kind of know what they are. Alright, so steps to graphing piecewise functions. You're going to start with the first function listed. You're going to graph as normal. Okay, so the first function is a line. You're going to graph the line just as normal. Then you're going to determine what I call the cutoff point. And that's the if x is less than or equal to -2, like that part of the piecewise. -2 would be the cutoff. Go to where that x value is on the graph and make a solid dot or open circle. And the solid dot or open circle is dependent on whether you have an equal to bar or you don't. Alright. We're going to erase the part of the line that does not fit in the domain and then you're going to start over with the next function. Okay, especially at first, the key to graphing piecewise functions is to go slow. Don't try to hurry through the problem, but take each piece at a time and deal with them separately. Although it's not part of the standard, we're going to do this example just so that if I ask you to do it, you kind of have seen it before. So write this piecewise function f of x, 2x minus 3, if x is less than or equal to -1, 1/4 x plus 5, if x is greater than negative 1. And we're going to evaluate it. We're going to find f of negative 2 and f of 0. Okay, now when you're asked to evaluate piecewise functions, keep in mind that this 2x minus 3, this might be a linear, but at some point it's going to be cut off, and that cutoff point is negative 1. So it doesn't exist for every single x value. Like, you can't plug in 2, because 2 is greater than negative 1, into this and technically have it work. Yeah, it'll work in there, but if we were to graph this, that line wouldn't even exist where x is 2. So, when you evaluate piecewise functions, you have to look at the value that you're supposed to be plugging in, so in this case, negative 2. And then you have to look at what piece it fits into. In this case, negative 2 is less than negative 1, so it's going to fit into the domain of that first function. So we're going to actually plug it in to just the first piece. And you would get f of negative 2 equals negative 7. Because this is a function, you should only get one answer, because functions, every input has only one output. You can't plug negative 2 into both pieces and get two different y values. Only one is true. Okay, so in this case, f of 0, again, you look at 0. Look at your domains and see which one it fits into. 0 is greater than negative 1, so 0 is going to fit into this second piece, your function. And you get f of 0 equals 5. Okay, so that's a very quick example of how to evaluate, just so that you've seen it before, but it's not part of the standard, so you won't have to do it on the test. But it's good just to know how to plug stuff into that type of function. Okay, let's go ahead and do a couple of examples together here. X 3/4 x minus 1, if x is less than or equal to negative 2, 3, if x is between 2 and 0, or sorry, negative 2 and 0, and negative 2x plus 3, if x is greater than or equal to 0. Okay, so this is the function that we're going to be graphing. I'm going to do each part slowly and separately, since this is the first time that we've seen it. I do want you to pay attention to the domains here. Domain, remember, is the x values that work for that piece. Where one leaves off, the other one has to pick up. You can't have any gaps here. So negative 2 picks up in the next piece to 0, and then it picks up at 0. Okay, so we should be able to see that there's a value for everything to exist, even if it's broken up into 3 different parts. So let's start with the first one here. Okay, so when you start with graphing piecewise, you just focus in and graph that piece like normal. So that's a linear function. The y-intercept is negative 1. The slope is 3/4. So I'm going to go graph my y-intercept at negative 1. Go up 3. 1, 2, 3. 1, 2, 3, 4. Make another dot. Notice I'm using pencil because I'm going to have to do some erasing here. And draw my line, just like normal. Okay. The next step for that piece is to find the cutoff. The cutoff point is where x is negative 2. So, I take my pencil, I go to where x is negative 2, I'm going to follow it down to where it hits my line. Okay, so my line is going to be cut off at that part. To show where it's being cut off, I either have to put a solid dot or an open circle. In this case, it's going to be a solid dot because you have the equal to bar. Okay, so I'm going to make the solid dot a little bigger there. And then I need to keep the part of the line where x values are less than negative 2. Well, x values that are less than negative 2 are to the left. So we're going to keep this part, excuse me, and erase everything to the right of that cutoff point. Okay, one mistake that students make is they automatically try to always erase at the origin or at the y-axis, but you do put that cutoff point there for a reason. You have to erase either to the right or to the left of that cutoff. So this piece or this line exists for x values less than negative 2. Okay, then we can go to the next piece, 3. Now technically this is like y equals 3, so there's no, there's no slope here. because there's no x, there's no mx plus b. All we have is my b value. So this ends up being a horizontal line through 3. So I'm going to go 1, 2, 3, and graph my horizontal line. Okay. Now, then we have to determine the cutoff point. This one actually has 2 cutoff points, -2 and 0. So I'm going to go to where x is -2 again, follow it up to where it hits the line I'm graphing right now. This one's going to have an open dot there. And then another open dot at 0. So I go to where x is 0, follow it up to where it hits my line, and make another open dot. Okay. Now, I have to decide what part of the line to keep. Because I have 2 cutoffs, I actually have 3 parts. The left part, the middle part, and the right part. I'll give you a little hint. When it's set up, when your domain is set up like this, you always are going to keep the middle because that looks like an and inequality. So you're going to shade or keep the part in the middle. But plus, any value between -2 and 0 would be what makes that inequality true. So we're going to keep this part and erase everything to the left of the cutoff and to the right of the cutoff. Okay, so we have our 2 pieces so far. Then we're going to graph our 3rd piece. Again, you just graph it like normal. So we're going to graph y equals -2x plus 3 has a y-intercept of 3. 1, 2, 3. Slope of -2 over 1. I'm going to go ahead and graph that. Alright. My cutoff point is 0. Now, because my cutoff point, because I go to where x is 0, followed up to where it hits my line, because I have that open circle there already, to show that there's both an open circle for one function and a closed circle for this one, you're going to make a dot, and then around that dot just make another like ring, and that'll show me that there's like 2 points there actually. And then we need to keep the part of the line where x values are greater than 0. Well, x values greater than 0 are to the right of 0. So we're going to keep the right part of the line and erase the left part. Okay, so you have 1, 2, 3. And you can see from your lines, well, first of all, that it'll pass the vertical line test. Also, that where one line stops, the other line picks up. Where one line stops, the other line picks up. So that should happen every single time. I'm going to go ahead and darken this a little bit. Okay. That should be your graph. Alright, I think we have time to do one more together. And then on the next page, we'll kind of go through this together as a review for class. Plus, I think this is where the 4 type problem is. Yep. Alright, example 3. -2/3 x plus 1. If x is less than or equal to -3. We'll go 3/2 x minus 1 if x is between -3 and 3, and then -4 if x is greater than or equal to 3. And we're going to graph all 3 parts. Okay, I'm going to start with -2/3 x plus 1. The y-intercept is 1. The slope is down 2 over 3. So down 2 over 3. And graph in your line. Okay. Then the cutoff point is at -3. So I'm going to go to where x is -3. Follow it up to where it hits my line. And I'm going to end up putting a solid dot there because I have an equal to bar. And then I need to keep the part of the line where x is less than -3. So x values that are less than -3 are to the left. I'm going to keep that part because that's what the domain states, and erase everything to the right of that cutoff point. Y-intercept is -1. I'm going to go up 3 and over 2. 1, 2, 3 over 2. I'm graphing my line. I have 2 cutoff points for this one, -3 and 3. So I'm going to go to where x is -3, follow it down to where it hits my line. In this case, I'm going to have to put an open circle there. And I'm going to do the same thing at x is 3. So go to where x is 3, follow it up to where it hits my line, and put an open circle. And then you're going to keep the part in the middle of the 2 cutoff points. So we're going to keep this little chunk of the line and erase the left piece, and the right piece. Okay, and then the last piece here is a horizontal line through -4. So 1, 2, 3, 4. The 1 cutoff point for this horizontal line is at 3, so I'm going to go to where x is 3, follow it down to where it hits my line. I need a solid dot here because of the equal to bar sign. Now I need to keep the part of the line where x values are greater than 3. Well, x values are greater than 3 to the right of 3. So I'm going to keep this chunk and erase everything to the left of it. Okay, again, you should be able to look at your graph when you're finished, see that it passes the vertical line test, and also that where one piece leaves off, the other one picks up. Okay, you shouldn't have them overlapping each other. They should stop, start, stop, start. So that's a good visual check to do, just to make sure that you erase the right pieces. The other little hint that I'll give you before we end is that a lot of times you can look at the sign. So like this is pointing to the left, and that's the part of the line that you end up keeping. Like we kept the left part of the line. So the only time it doesn't work is like with stuff like this. But anytime you just have one inequality, you're going to keep the part of the line where the arrow is pointing. So like the arrow is pointing to the right, we kept the right part of the line. So that's the other little hint I can give you. And then tomorrow, as a class, we'll go through one more example together, probably, and then work on 4 type problems for piecewise. Okay, so you're done.